Hey, everybody. These are going to be the example problems from chapter 12. So 12.1 is called the weight of a room full of air. And it reads, find the mass and weight of air at 20 degrees C, T equals 20 degrees C, in a living room with 4 by 5 by 3. So the volume is 4.0 meters times 5.0 meters times 3.0 meters. And the mass and weight of an equal volume of water. Okay, so we're going to need the density of air and water. So let's go ahead and do that. When it's pretty cool because that's on table 12.1 and that table is right above us. So here we go. Densities of some common substances. Air, and this is going to be rho air, is going to be equal to, and this is 1.20 kilograms per meter cubed. That air is pretty heavy. And water. Let's see, where is water? Why don't I see water? Water is going to be 1,000 kilo. Yeah, I should know water. Everybody knows. You should always know water. Water is 10 to the 3 kilograms per meter cubed. Okay, let's go ahead and do this. All right, so rho equals m over v. So we're going to find the mass of it, right? So m is going to be equal to rho times v. So let's go ahead and do that. For m of air, you're going to get 1.20 kilograms per meter cubed times 4.0 meters times 5.0 meters times 3.0 meters. And then the mass of water is going to equal to 10 to the 3rd kilograms per meter cubed times 4.0 meters times 5.0 meters times 3.0 meters. And the mass of air is going to be 72 kilograms. This guy. And the mass of water is going to be mass of water is going to be, let's see, 6 times 10 to the 4th kilograms. All right. And then to find the weight, I guess we need to find the weight. You're going to multiply them by 9. Weight of air is going to be 72 kg times 9.8 meters per second squared. That's going to give you 700 newtons. And the weight of water, let's see, I'll do it here, weight of water is going to be equal to 6 times 10 to the 4th kg times 9.8 meters per second squared. And that's going to give you 5.9 times 10 to the 5th newtons. 5.9 times 10 to the 5th newtons. All right. And that's the deal. All right. We have example 12.2. Is called force of air. And it reads, in the room described in 12.2, what is the total downward force due to air pressure at 1 atm? All right, so let's go ahead and do that. All right, so pressure is defined as force divided by area. So we're looking for force. So force is going to equal pressure times area. And we were given 1.00 atm, 1 atmosphere. And in your book on page 371, 1 atmosphere is also equal, it tells us it's equal to 1.013 times 10 to the 5th pascals. All right, so force is going to equal to 1.013 times 10 to the 5th pascals times area, which is going to be on that problem. On the other problem, it says let's see, the floor is 4 meters times 5 meters. So this is going to be 4.0 meters times 5.0 meters. And you're going to have a force of 2.2 times 10 to the 6 newtons. 2 times 10 to the 6 newtons. Your book goes ahead and converts it into pounds. It's in pounds, it's going to equal to 4.6 times 10 to the 5th pounds. That's a whole lot of pounds. That's a whole lot of pounds. All right. That was 12.2. 12.3 is finding absolute and gauge pressures. So it's finding absolute and gauge pressures. All right, and it reads, water stands 12 meters deep in a storage tank whose top is open to the atmosphere. What are the absolute and gauge pressures at the bottom of the tank? Okay, so the pressure is absolute. P equals P naught, which must be the atmosphere, plus rho GH. And this is P absolute. And P gauge, let's call that PA. And P gauge is going to just simply to be rho GH. Rho GH, or it has this minus P naught, which is rho GH. All right, so let's see, we've got a, this guy is going to be 1 atmosphere, which we have redefined that as 1.01 10 to the 5th pascals plus 10 to the 3rd kilograms per meter cubed times 9.8 meters per second squared times H is what, 12 meters, 12.0 meters. And that's going to give you, boom, that will be, what do they have there? 2.19 times 10 to the 5th pascals. 2.19, 10 to the 5th pascals. And then without it, it's going to be just rho GH, 1.01 times 10 to the 5th pascals. Oh, sorry, I was writing down the wrong thing. Let me just erase that. I just need rho GH. Okay, I'll do it in red. That'll be cuter. We're gonna get, I need this. There we go. All right, we're gonna have 1,000 kgs per meter cubed times a 9.8 meters per second squared times 12 meters. And I don't know what that is. Let me knock that out real quick. On clear 10 to the power of 3 times 9.8 times 12 equals overflow air clear 10 power of 3 times 9.8 times 12, right? Yeah. I get 1.17 times 10 to the 1, 2, 3, 4, 5, 5th pascals. Is that what they get? They get 1.18 times 10 to the 5th. Okay, let's see. Yeah, if I were being completely honest and rounding properly, I get 1.18, and so does the book, and you should too. All right, so enjoy. And that was 12.3. All right, this is called A Tale of Two Fluids, and it says a manometer tube is partially filled with water. Oil which does not mix with water is poured into the left arm of the table until oil and water interface at the midpoint of the tube is shown in figure 12.10. And it kind of looks like this. I'll give you, got this little guy. Here's your tubes. That's just one tube, you guys. Here's your other guy. And you got, let's see, they meet here. In this side, you got water. And in this side, you got oil and water. Okay. And now it's asking to find a relationship between the height of the oil and height of the water. Well, you know the pressure is going to be the same on either side. So P oil equals P water. So that's going to be rho GH oil equals rho GH water. And G obviously is the same. So we'll just do H oil is going to be equal to rho water divided by rho oil times H of H2O. And that's your relationship. That was 12.4. All right, this is example 12.5. And in 12.5, we've got a 15 kilogram nugget of gold. Wouldn't that be nice? 15 kg mass. Rho of gold is going to be 1.93 times 10 to the third times 10 to the third kg per meter cubed. And I am asked to find its held up by a string. We're asked to find its tension in the air and the tension in the water. So let's go ahead and do the tension in the air. The tension in the air is just going to be the weight of the whole thing, right? So the mass times M times G. T air equals mg equals 15 kg times 9.8 meters per second squared. Let's see, it's going to be about 150 newtons, but let's get an exact value. Book uses 147 newtons. I'm going with that. All right, I'm going with 147 newtons. All right, now to find, and they also go through the process of subtracting the buoyant force in air. You can go through that if you like. It's trivial compared to the weight of the object. So we're just going to ignore that part. But in water, it's not trivial. So what we want to know, the tension in water is going to be equal to the tension in air minus the force buoyant of the object in water. And the force buoyant, by definition, is going to equal to the weight of the displaced water. So we're going to have the volume of the water times rho times G, right? Okay, so what we're times G, right? We need to know the weight of the displaced water. Okay, so what we've got going here is the buoyant force. So we need to find the volume of the object. V of the object is going to equal to, we've got rho equals mass over V, so I switch these. It's going to equal, example 12.6 is flow of an incompressible fluid. And it says, incompressible oil of density 850 kilograms per meter cubed is pumped through a cylindrical pipe at a rate of 9.5 liters per second. So V equals 9.5 liters per second. The first second, the pipe has a diameter of 8.0 centimeters. So for T1, D equals 8.0 centimeters. The second, what is the flow speed of the oil, what is the mass flow rate? All right, we are going to use equation 1211. Equation 12.11 is says dV dt, the volume flow rate of a fluid equals the area times the velocity. And we're looking for that speed of flow, that velocity. All right, so we've got V equals dV dt over the area. And so we've got, this is going to equal to 9.5 liters per second. And then we've got to convert that into meters. So we've got times 10 to the negative 3 meters cubed per liter. And that's going to be divided by the area, which is going to be pi r squared. So it's pi, and that's diameter. So 8 centimeters is going to be 0.1204 meters, quantity squared. Is that 8 centimeters? Yeah, 0.04 meters, quantity squared. And that V is going to equal to 1.9 meters per second, 1.9 meters per second. And that's when T equals 1, and that diameter is 8 centimeters. Part B is asking us to find the flow rate in the second section of the pipe, which has a diameter of half the first section. So we're going to do the same process. V2 equals dV dt over the area. That's going to be equal to, oh, they did it a different way, and I like the way they did it, and we're going to go ahead and do it their way. We're going to use the continuity equation. So V2A2 is going to equal to V1A1. I'm sorry. Let me clear that. I made an error. V2A2 is going to be equal to V1A1. All right, so we're going to go ahead and solve for V2. So V2 is going to be equal to V1A1 over A2. So this is going to be equal to, we got a value there, 1.9 meters per second. So we have 1.9 meters per second times A1 is pi times 0.0404 meters quantity squared. That's A1 pi r squared. And then this is going to be pi times, it was half, 0.02 meters quantity squared. And then that whole thing is going to equal to 7.6 meters per second. And that is example 12.6. 12.7 is entitled Water Pressure in the Home. You enter a house through a pipe with an inside diameter of 2 centimeters. So let's go ahead and just nip that in the bud. R is going to equal to 0.01 meter. At an absolute pressure of 4 times 10 to the 5th Pascal. So R1, P1 equals 4 times 10 to the 5th pascals. A 1 centimeter diameter pipe leads to the second floor. So let's go ahead, and R2 is going to be equal 1 is going to half of that. So that's going to be 0.005 meters. 5 meters above, so delta H equals 5.0 meters. When the flow speed of the inlet pipe is 1.5 meters per second, so V1 equals 1.5 meters per second. Find the flow speed, pressure, and volume flow rate in the bathroom. And we're going to do that. All right, we're gonna find the yada flow speed first. We're gonna use that continuity equation. So we're going to say V2 equals A1 over A2 times V1. And we can take those pi things out there, pi r squared. It's pi r squared over each. So it's going to be, do I have to change it? Why are they using centimeters? Oh, because the centimeter squared drops out too. So it's going to be 0.01 meter quantity squared divided by 0.005 meter quantity squared times the V1, which is 1.5 meter per second. And this is going to give us a V2 is going to equal to 6.0 meter per second. All right. Now we're going to use Bernoulli's equation to find that pressure. We're going to, pressure. So it's going to look like P2 minus P1 equals 1/2 rho V2 squared minus V1 squared. We just got that value. Minus rho G delta H. Delta H. And so this is going to be equal to, let's see, 1/2. And rho is water, so that's going to be equal to 1,000 kilogram per meter cubed times let's see, where did they get 36? Let me pause this and come right back. They got 36 because it's squared. So yeah, my bad there. So they're going to use 6 squared is 36 meters squared over second squared minus, and what was 1.5 squared is going to be 2.25 meters squared over second squared minus 1,000 kg meter cubed times 9.8 meters per second squared times delta H was 5 meters, right? 5 meters, 5 meters. And that whole thing is going to give us, we had P1 there, which is 4 times 10 to the 5th pascals. So that's going to give us a value for P2 of 3.3 times 10 to the 5th pascals. P2 equals 3.3 times 10 to the 5th pascals. All right. Okay, finally, I am asked to solve for the volume flow rate. So we have dV dt equals A2 V2. So we have our dV dt equals pi. V2 is 0.005 meters, and that's squared. I mean, that's A2, I'm sorry, my bad, times 6.0 meters per second. And this is going to be equal to 4.7 times 10 to the -4th meters cubed per second. And then we need to convert that into a liters. And that is going to be equal to 0.47 liters per second.